find the first four derivatives with respect to x, or y is ln of 1 plus sine x. Let's review the chain rule firstly. If we need to take the derivative of the function which is raised to some power, for example ln to the power of 5 of x, we apply the same rule as for the derivative of x to the power of 5 and x to the power of 5 derivative. It's 5x to the power of 4, but instead of x we write this function, so it becomes 5 ln to the power of 4 of x and multiplied by this function derivative, so multiplied by ln of x derivative, and is equal to, it may be a chain rule again, and how to find the derivative, it's the next problem, but here we can see that it's directly from the table. Ln derivative, it's 1 over x, so it becomes 5 over x ln to the power of 4 of x. If there is no power but more complicated argument, for example if it's ln of cosine x and we need the derivative, we apply the same rule as for ln derivative, it's 1 over x, but instead of x we write this argument, so it becomes 1 over cosine, and according to the chain rule we multiply by this argument derivative, so multiplied by cosine derivative. Cosine derivative negative sine, so it becomes negative sine over cosine. If it looks like this, ln to the power of 5 of cosine of x and derivative, we do according to the power firstly, so it becomes 5 ln to the power of 4 of cosine multiplied by this derivative, so ln of cosine of x derivative, and we can see that it's again a chain rule and it becomes 5 ln to the power of 4 of cosine multiplied by 1 over cosine multiplied by cosine derivative, which is negative sine of x. So we can see the y is ln of 1 plus sine x, and the first derivative becomes, we can see that there is no power, so it becomes 1 over 1 plus sine and multiplied by 1 plus sine derivative, which is just cosine, so it becomes cosine over 1 plus sine. So the second derivative becomes, we can see that it's the ratio, and we should apply the quotient rule, and quotient rule says that u over v derivative is denominator squared in the denominator, and there is in the numerator the next expression, numerator derivative by the denominator minus the numerator multiplied by the denominator derivative. So it becomes 1 plus sine squared, cosine derivative, it's negative sine, multiplied by 1 plus sine, minus cosine numerator multiplied by the derivative of the denominator, 1 plus sine derivative, it's cosine, so we can write that minus cosine squared, and we can see that it is equal to minus sine squared minus cosine squared over 1 plus sine squared, and we can see that it becomes minus sine squared plus cosine squared, and sine squared plus cosine squared of the same argument, it's just 1, so it becomes minus sine minus 1 over 1 plus sine squared, and we can see that we can factor out -1, and it becomes -1 multiplied by sine plus 1. We can simplify and it becomes -1 over 1 plus sine of x. Hence the third derivative becomes, we can apply quotient rule again, or we can consider it as -1 plus sine x to -1 and derivative, and apply a chain rule according to this rule. So it becomes this minus and power exponent -1, 1 plus sine x to -2, and 1 plus sine derivative, which is cosine. It becomes plus, so we can see that it becomes cosine over 1 plus sine squared. Or if we apply a quotient rule, it becomes denominator squared. In denominator, in the numerator, we get -1 derivative with 0 minus just numerator multiplied by the derivative of the denominator, 1 plus sine derivative, which is cosine, and we can see that we get just cosine over 1 plus sine squared. And this third derivative, oh, it was the third, so the fourth derivative, and apply a quotient rule again. It's 1 plus sine squared and squared, so to the power of 4. Numerator derivative minus sine multiplied by the denominator minus numerator multiplied by the derivative of 1 plus sine squared. So it's a chain rule. So it's 2 1 plus sine multiplied by 1 plus sine derivative, which is cosine. So we can write cosine squared. And we can see that we can divide each term by 1 plus sine. And we can leave in such form. And the next question is to get the Maclaurin series for a given function, and the Maclaurin series is y of x is y at 0 plus the first derivative at 0 times x plus the second derivative at 0 x squared over 2 plus the third derivative at 0 x cubed over 3 factorial, which is 6, plus the fourth derivative at 0 x to the power of 4 over 4 factorial, which is 24, plus so on. And we need function at 0. We can see that it becomes ln of 1, which is 0. And the first derivative at 0 is 1 over 1 is 1. So it's 0, it's 1. The second derivative at 0, this one, we can see that it's -1 over 1 is -1. -1. This third, this one at 0, 1 over 1 is 1. And the fourth at 0 is 0 minus 2 over 1 is -2. So it becomes x minus half x squared plus 1 over 6x cubed minus 1 over 12x to the power of 4. And let's check. Yes, it's correct. Plus 1 over 6. Yes. So the next question, deduce the Maclaurin series up to and including the term in x to the power of 4 for the next functions. Y is ln of 1 minus sine. So we have the Maclaurin series for ln of 1 plus sign, but we need for ln of 1 minus sign. And we know that sign is odd function, and it means that sign of negative x, it's minus sign of x, and we can move this minus into argument, and it's ln of 1 plus sign of negative x, and hence it becomes y of negative x, and we can get the required Maclaurin series if we substitute negative x for x into this expression. Hence y becomes negative x minus a half, negative x squared is just x squared, plus 1 over 6 negative x cubed, so it's minus 1 over 6 x cubed, and negative x to the power of 4, it's x to the power of 4, so minus 1 over 12 x to the power of 4. The next, ln of cosine, and we need connect cosine and 1 plus sine or 1 minus sine. And what do we know? We know the metric identity that sine squared plus cosine is 1, and we usually use this formula if we need connect sine and cosine. And also we know some rules for ln, and idea is the next. If we consider 2 ln of cosine, and it's ln of cosine squared, it's because there is such rule for ln, formulas are given in the data booklet, and it becomes ln of 1 minus sine squared x, and ln of 1 minus sine squared, 1 minus sine squared, this formula is squared minus b squared, so it becomes ln of 1 minus sine multiplied by 1 plus sine, and ln over product is the sum, so it's ln of 1 minus sine plus ln of 1 plus sine, and it becomes, it's ln of 1 minus sine, so it becomes minus x minus a half x squared minus 1 over 6 x cubed minus 1 over 12 x to the power of 4 plus this x minus a half x squared plus 1 over 6 x cubed and minus 1 over 12 x to the power of 4. And you can see that it's 0, 0, and notice that it's 2 times ln, so ln of cosine becomes, we can see that minus a half, it's negative 1, divided by 2, it's again minus a half x squared, and minus 1 over 12 minus 1 over 12, and divided by 2, it's just minus 1 over 12 x to the power of 4. And the next, y is tangent, and again we need to connect this tangent with ln of 1 minus sine, 1 plus sine, or ln of cosine, and actually this example, we can see that if we apply a derivative, if we consider the derivative of ln of cosine, we can see that it's minus tangent. So So we can see that tangent x, it's minus ln of cosine derivative. So series for tangent is minus, and this minus a half x squared minus 1 over 12x to the power of 4 plus so on derivative. Hence it becomes x squared derivative 2x, so it's minus x minus just x, and 4x cubed minus 1 over 3 plus 1 over 3 x cubed, and plus so on. And the next, hence calculate this limit. It becomes limit x tends to 0 tangent of x squared. So we use this series but substitute x squared for x, so it becomes x squared plus 1/3 x to the power of 6 plus so on, divided by ln of cosine. Ln of cosine is minus a half x squared minus 1 over 12x to the power of 4 plus so on, and its limit x tends to 0, and we divide each term by x squared, and hence we get that numerator becomes 1 plus 1/3 x to the power of 4 plus higher powers of x, so we can write that 1 plus powers of x, and denominator becomes minus a half plus powers of x, and if we substitute 0 for x, we get that all these terms are 0, hence we get just 1 over negative a half, so it's negative 2. And that's all for this question.